Hi. General relativity. General relativity is basically that the larger an object is, the more attraction it's going to have to something else, which basically, I have a notebook here. This notebook is not a very large mass. I am larger than the notebook. And because I'm larger than the notebook, theoretically, the notebook is attracted to me. I'm also attracted to the notebook, but the notebook is more attracted to me because I have a larger mass. And if you take both the notebook and and you did an experiment to see, what has the largest mass in our general area? Well, the easy answer would be obviously the Earth. So if I took the notebook and me, and I dropped the notebook, it would obviously fall towards Earth, because Earth is the largest thing in our general vicinity. And that basically is kind of how gravity and relativity works, that the larger an object is, the more attractive force it has. But everything from the smallest atoms have an attractive force. It's just that the more dense and the more dense an object is, the larger it is, then the more attraction it's going to have. So obviously between the notebook, the Earth, and the Earth is the most dense and has the largest mass, so therefore we are both attracted to the Earth. The notebook and I are more attracted to the Earth than we are to each other, and so we would both fall to the Earth. I am seated, but if we were not on Earth, if we were in outer space in a vacuum, we would be floating. And as you can tell from the camera, I'm not floating. But yeah, basically, general relativity is the more massive something is, the more dense it is, the greater the pull. But every object has an attraction to another. And that's how things like galaxies form and so on, because a galaxy spins, and then over time it kind of pulls out and forms what you see the most common spiral galaxies, with kind of a ball in the middle, and then it kind of thins out towards the end, as you would if you spun, say, a ball of some sort of loose gel. It would take on like a curve, like a bell-shaped curve, but a very elongated bell-shaped curve. And that's how you see the galaxies form, because the gravity between the galaxies kind of holds them all together. And in the center of the galaxies are supermassive black holes, which kind of pull everything towards it to kind of hold everything together. Black holes are a place where matter is so dense that light and everything else is unable to escape it. As for the world ending in 2012, well, I just think that's ridiculous. What could possibly happen? Jesus is not going to come back. I am, part of my heritage is from Central and South America, so I do have a little bit of Mayan in me, and I don't believe that the Mayan believed that the world would end in 2012. If the Mayan culture was still around today, they would just start the calendar over. I think it's a bunch of crap. The world is not going to end on December 21st, 2012, or in 2012. And the only way something bad is going to happen on that day is if somebody makes it happen. Some sort of nut decides to launch a nuclear weapon, for example, or release a virus, bioterrorism. That's the only way something bad is going to happen on that day. It's not going to be something natural and catastrophic. And if there was, by any sort of chance, it would just be a coincidence. An asteroid is not going to hit the Earth is not going to explode. I'm going to be here on December 22nd, 2012, and in 2013, unless I die of natural causes beforehand. So the world is not going to end in 2012. I think that's an idiotic proposition. It's just so idiotic. I mean, really. Based on a bunch of old superstitions, you're gonna think the world's gonna end? Yeah, right. And if I'm wrong, so what? I'm dead. Not like I'll care. Let's see. Covered all that. Space-time is basically the fabric on which the entire universe rests. Not to say that the universe is, well, I guess some do call it a flat universe, but, you know, basically it's like my notebook. You know, you can have it bend so there are peaks and valleys. And towards the middle here would be where something large like a star like our sun would be. And then the planets orbit around, continually falling in to the warp in space-time. You know, just like I said, think of it as a notebook where, you know, things are traveling in a circle, but they're slowly going down and down and down towards the object of the largest mass, which in the case of our solar system would be our sun. But in our case, our sun is going to go red giant before Earth collapses or Earth falls into it, so it'll be swallowed by the sun before we actually fall into it. But space-time is just made of peaks and valleys where black holes and stars and planets are, and the objects basically just kind of fall, kind of like gravity, like my notebook falling. You know, they would fall, but they fall towards the object of largest density, and a lot of the times they do that in a circular fashion, kind of like a downward spiral. As for the question as if there are more habitable planets in our universe. There has to be. You know, even if there's a 1 in a billion chance of a star having another habitable planet, then there's 100 billion stars in our galaxy. That means there's 100 of them in our galaxy alone, in the Milky Way. And so that just means, yeah, it might not be a place where we can get to, but do they exist? Of course they exist. You know, even if we were running a trillion chance, there are still trillions of stars out there. People don't understand that, you know, stars are are like grains of sand on a beach or pieces of dirt. They're just so plentiful that the chances of there being another planet out there in the Goldilocks zone with our atmosphere, it just has to exist. So there are other habitable planets out there. It's just more of a question of whether we can get to them. That would be the question. Can we get to these other habitable planets in the next 4 billion years or so, by the time our sun starts to die off? That would be what we need to find out. We also need to find them, but they are out there. I think time travel backwards in time through wormholes is impossible. Time is like an arrow. You know, it just goes one way. It has a starting point, and from that point, it just goes on. You know, it has a start, but it has really no end. Like I was saying earlier, the end of the universe is just going to be loss of motion, but it just goes on. But it has a starting point, and you can't go back. You know, there's no paradox. You can't go back and kill your own grandfather, because if you did, you'd never exist. So, I mean, you really can't go back in time. Now, whether wormholes can be used to travel forward into the future, that I have no idea. But the arrow of time is very clear. Things happen in a precise way because time does not go backwards. Time only goes forwards. So, you can't go back. This, not even with the wormhole. You know, time is very clearly defined. There is a starting point. I will never be able to go back to this second now. As for parallel universes being formed through black holes, I think it is a possibility. There is a theory of universe creation that or universe formation that says that we come from black holes of other universes, and our universe is just the matter that was spat out from that universe. So I know parallel universes is not really a very common, well, a lot of people believe in parallel universes, but it's not the norm in physics. At least I don't think so. But I believe that there are parallel universes. I don't know if there's a parallel universe based off of, you know, did I go right or did I go left? Every time I decide to go right instead of left, a parallel universe forms. I don't believe in that. But I think that there are other worlds or other universes other than our own. And whether black holes can lead to them or not, that I don't know. But I do think that black holes can lead to parallel universes in theory. Now, I'm not willing to go to a black hole and test one myself, but I do think in theory black holes can lead to a parallel universe, especially if the formation of our universe was by a black hole. It just, you know, makes sense. As for the data on whether black holes exist or not, well, it's very easy to prove, really. I mean, space-time shows that in the middle of our galaxy, the Milky Way, there should be something very large and dense, and we just can't see it. Something sucks light into it. And so we theorize that it's a black hole. And not only that, I will provide a link that shows a star actually being ripped apart by a black hole. So yes, data on black holes does exist. Not only does, you know, space-time and galaxy formation depend on black holes, and space-time proves black holes, but we've also now seen stars ripped apart by a black hole. So the data on black holes is there, and they do exist. There's no doubt. Let's see. Okay, that's it. Bye.